Welcome, and get ready to dive deep into a topic that's quite literally shaping our future: wireless communication in 2030 and beyond.
Well, the evolutionary path towards 6G involves a continued yet significantly accelerated evolution of 5G advanced functionalities. This happens specifically through the 3GPP releases, which define the standards. Now, maybe it's helpful to take a quick look back at how we got here, tracing the remarkable evolution of wireless communication over the past few decades, and then projecting forward towards 6G and beyond to understand the truly remarkable leap in capabilities we're about to witness. This historical perspective helps frame the scale of 6G's ambition.
Good idea. A little history lesson.
Our historical view, from 1G to 5G, illustrates a consistent and accelerating drive for more advanced, faster, and more capable communication. 1G, introduced in the early 1980s, was all about rudimentary analog voice communication. It brought mobile phones to the masses, but call quality was often poor, security minimal, calls easily intercepted.
The brick phones.
Those were the days. 2G, arriving in the early 1990s, marked the pivotal shift to digital voice communication and introduced essential services like SMS text messaging, a significant step in both security and network capacity. 3G, launched in the early 2000s, brought the mobile internet to our phones, enabling basic data services, rudimentary web browsing, multimedia messaging, albeit at relatively slow speeds that often tested our patience.
I remember waiting for pages to load.
We all do. 4G, specifically LTE, which became widely prevalent in the 2010s, delivered true mobile broadband. Speeds typically up to 1 gigabit per second in ideal conditions, latency reduced significantly to around 50 milliseconds. This generation truly enabled widespread modal video streaming, robust online gaming, and a host of new data-intensive online applications that transform daily life.
4G really changed things.
It did. And now, 5G, standardized as IMT 2020, has been rolling out since roughly 2020. It focuses on three primary scenarios: enhanced mobile broadband, eMBB, for high data rates; massive machine-type communications, MMTC, for connecting vast numbers of IoT devices; and ultra-reliable, low-latency communications, URLLC, for critical real-time applications. Its peak data rate is specified at an impressive 20 gigabits per second, with a user experience data rate targeted at 0.1 Gbps, latency targeted less than 10 milliseconds, supports mobility up to 500 kilometers. Connection density jumped to 1 million devices per square kilometer, area traffic capacity set at 10 millipees per square meter. Crucially, 5G aimed for 3x spectrum efficiency and a remarkable 100x energy efficiency compared to 4G, showing that growing emphasis on sustainability. Key technologies enabling 5G included millimeter wave frequencies, massive MIMO antenna systems, and ultra-dense networks, UDN, with numerous small cells.
So 5G already brought massive improvements across the board.
Indeed.
Let's start with the official timelines. Standardization bodies.
Let's first look at the official standardization timelines, which provide a formal roadmap for the industry. ITU are IMT 2030. The International Telecommunication Union Radio Communications Sector, ITU-R, began its formal framework process for IMT 2030, which broadly defines 6G back in 2019. The critical phase for establishing detailed requirements and evaluation criteria for 6G technologies is set to continue until 2026. Following that, the period from 2026 to 2028 is designated for rigorous evaluation of proposed technologies and building consensus among global stakeholders. Final approval for the comprehensive 6G framework, setting the stage for global harmonization, is anticipated around 2030.
So ITU sets the big picture by 2030. What about 3GPP, the Mobile Standards Group?
3GPP. They officially committed to 6G specifications in late 2023. Currently, Release 19 is underway and expected to be completed by mid-2025. This release already includes preliminary studies for 6G, delving into areas such as integrated sensing and communication, ICs, and new frequency range 3 FR3 channel modeling. So the seeds of 6G are already being planted within current 5G advanced work. Release 20, which will serve as that crucial bridge between 5G advanced and initial 6G, is slated to start in the second half of 2025. It will focus on further enhancements to 5G advanced while simultaneously initiating a series of dedicated 6G studies covering use cases, service requirements, deployment scenarios, and core technology components. The first official 6G release specification, known as Release 21, is expected to be available in the 2029-2030 timeframe, marking the official blueprint for initial commercial deployments.
So Release 21 around 2029-2030. When do we expect actual commercial service?
Commercial deployment. Based on these ambitious and globally coordinated standardization timelines and ongoing industry developments, the general expectation in the wireless industry is that the first commercial deployments of 6G will commence around 2030, with a more widespread rollout accelerating throughout the early 2030s. We invite you to explore the full analysis. A comprehensive and detailed review of the Alpert Research Team's presentation on the future of wireless communication is available at the following link.